Hello students, welcome back. Let's resume our discussion in section 3. We went through the chain rule and some exercises on elementary chain rule. I hope you didn't just watch me doing all these. I hoped you stop the playback and go through some of the problems on your own and then resume like that, because mathematics is not a spectator sport. If you just watch somebody else doing, then when you have to do, you cannot reproduce the same thing that you watched. You actually have to do it on your own. Now, assuming you mastered these kind of problems, let's go ahead to the higher level problems. The kind of problems that you'll have to apply chain rule twice, for example, because we have exponential function, that's outer function, and then we have square root function, that's a middle function, and then we have x squared plus 1. That's all the way inside. Not just two functions here, but three functions. See the difference? This is a compounded function of just two functions, derivative of f of g of x. But this one, the derivative of f of g of h of x, basically. How do you handle it? Well, one step at a time. So y is e to the x squared plus 1 to the 1/2 power. So y prime is, let's see, outermost function is exponential, and exponential always stays the same. And inside never changes, always stays the same. So I don't change anything. And then we have to multiply the derivative of the inside. And the derivative of the inside, this is another chain rule. 1/2 and this thing to the negative 1/2 power. And then by chain rule again, I have to multiply the derivative of the inside, which is 2x. Like this. And then you can simplify if you want to. So we have first chain rule, which resulted in this big bracket. And when you calculate this, we did another chain rule, and that resulted this smaller bracket. And then you can simplify. Here you go. And then after simplification, well, we get something like this. Too complicated. Is it really a simplification? Maybe I don't do anything. Just cross everything out, and maybe it's better to stop at the first line. Okay, here's the next problem. Again, try it on your own first. Y equals to this whole expression to the 1/2 power, because square root is equivalent to 1/2 power. Now, what's the derivative? The outer function is 1/2 power function, so 1/2. Nothing changes inside. And negative 1/2 power after subtracting 1. And then, by the chain rule, I have to multiply the derivative of the inside. But then again, this derivative computation here, that'll require another chain rule because we have exponential of something like this. Are you up to it? Okay, let's try. Derivative of this 2x squared, that's 4x, and derivative of this plus 0, that's plus 1 because plus 0, so no problem there. And then let's go with this exponential. Exponential always stays the same. And then, by the chain rule, I have to multiply the derivative of the inside, the derivative of this 3x squared plus 2x function. A little of warning here. This x plus 2 is coming from this exponential, because is coming from the chain rule for this guy. Now, if I multiply this 6x plus 2 to this entire factor, that'll be wrong because that multiplication applies to this one as well. But this 6x plus 2 came from this exponential. It did not come from these. So this will be wrong. I have to get this bracket away and then move it all the way outside like this. Whether you use bracket or parenthesis or brace, it doesn't matter. In any case, this should be multiplied only to exponential. That is the key point that I want you to make. Here we go. Here, I multiplied it to the left-hand side because it is customary to multiply something more complicated to the right-hand side. So instead of multiplying 6x plus 2 to the right-hand side here, I just multiplied 6x plus 2 to the left-hand side of this exponential. Otherwise, the same. So what do you think? Suddenly things became far more complicated, right? Well, do you have to do all these? In order to get an A, yes, you have to cover everything like blanket. But for most of the students, 2 chain rule problems are kind of like pushing the envelope. So if you're unable to do these kind of problems, you'll still be able to pass successfully, B or higher. Yeah, you can do that. Of course, you have to do these kind of problems without much trouble. How about these problems? You have to combine chain rule with other rules like product rule, quotient rule, one way or the other. Okay, let's go ahead and do that. This kind of problem should be okay. First, you have to observe that this is a power function of 1/2 power because I have square root. Okay, no more power here, no more radical, and everything is in the power forms, no problem there. Now, how do I take the derivative of this? Outside in, that's the rule of thumb. So outer structure here is clearly the product rule. Do you see that? Product of this times that. Do you see it? Therefore, it's going to be u prime v plus u v prime. Okay, like this. That's the structure. All right, the derivative of the first function here, that's going to be 6x plus 2. That wasn't too bad. Okay, now the derivative of the second function. Oh, this one requires a chain rule. Okay, take a deep breath and consider this as a new problem. Power comes out as coefficient, 1/2 power, and then we get negative 1/2 power, right? And nothing changes inside. And then finally, like a dangling chain, multiply the derivative of the inside. 15x squared minus 1 over x. Remember, the derivative of log function is 1 over x. That'll complete the problem. Remember, this chain rule came from this second factor here. So product rule and then the chain rule. A little bit difficult, but this is a kind of problem everybody should be able to handle. Here's the answer key. Now, how about this? Again, a little bit difficult, but it's not outrageous. G of u is this whole expression to the 1/2 power because we have square root. Power from conversion is usually the first thing you should do. By the way, let's use bigger font. Okay, let's go ahead and do that. G prime of u is, well, what's the outer function? Outer function is 1/2 power function. So let's use a chain rule. And that's negative 1/2 power, right? And nothing changes inside, so let's just copy and paste. And then you have to multiply the derivative of the inside. Make sense? Now, what is the derivative of the inside? Well, that's the derivative of this quotient. So it looks like you have to do your quotient rule here. This thing squared. And then over here, you have to use the quotient rule, u prime v minus uv prime. So you get 2u plus u, no, not u, 2u plus 2, and then u cubed minus 3u, that's the denominator, and then numerator, u squared plus 2u, and then the derivative of the denominator, 3u squared minus 3. Did I do this right? Please check. Oops. Okay, there you go. So in this kind of problem, filling out the bracket is actually a separate new problem. So get the product rule, get the chain rule first, and then filling out this bracket here is actually a separate new quotient rule problem. Again, a bit complicated, yeah, but everybody should be able to handle this. You see, if you have 2 or more chain rules coming in, it can be really complicated. But it's just one chain rule and quotient rule. One chain rule and the product rule. A little bit complicated, yes, but you should be able to handle it. I cannot say the same thing to the last problem here. Anyway, here's the answer key. As for the last problem here, well, I'll leave it in an exercise for you. You'll have to use multiple chain rules here. Okay, let's take a break and then let's come back and complete section 3 in a separate video.